Everyone, it's Casey from the Montreal Student Network, and today we're going to be looking at functional groups. Now, this is normally something that'll be introduced before you start looking at alcohols and alkenes, along with alkyl halides and all those types of introduction reactions in Organic Chemistry 1. One important thing you're going to need to know is which ones are required for your specific course, because some teachers will only require you to memorize a few of them. For example, alcohols, alkyl halides, and the ether right over here. Those are the ones you're going to need to know no matter which course you're taking. If you don't see those in your course, you're definitely not getting a proper education. I'll say that right now. You see that this list does go down, and there's a lot on this list, and not every teacher will require you to know everything here. So you don't want to, memorize stuff you don't need to know, because there's a lot of information behind each of these functional groups, and if your course doesn't require it, there's no point memorizing it, and you're just going to forget it, and you won't be able to actually appreciate what that functional group contributes to a structure. So make sure you ask your teacher which ones you need to know. I'm going to go over every one of them. So the ones that you need, I'll mention this video. I'm not going to give too much explanation on what they do. For example, an alcohol OH group or hydroxyl group will give polarity to a compound. They all have their different uses, but I'm just going to go over exactly what name is associated with what compound, or which functional group for that matter. So before we get started, I've talked about what the R means. It means the rest of the compound, and I'll give you guys a little example over here. Say we had a little carbon chain over here, and we had a functional group. So say a group that's not made of carbon, just something unique that we'll be seeing. Say we have an OH group right over here. The functional group will be obviously the OH over here, and then the R would be the rest of the compound. So I'll just use the white right here to signify rest of the compound, right to do, and that will be your R. And I'll put FG over here for functional group, and I'll point to this right over here. So that's just what we're going to be using. The R, the rest of the compound, doesn't need to be only a carbon chain. Obviously, you can have another functional group. You can have another OH on it somewhere right there. But when, for the terms of what we're using, R is just whatever is not the functional group that you're talking about. Seems a little weird, but you'll see what I mean as we go along. So starting off with the two most common ones, when you have an OH group attached to your compound, it's automatically considered an alcohol. If you have more than one OH, you'll start to become diols, and it has, different names like that. But that gets a little bit advanced for Organic Chemistry 1. It moves into the second one. So really want to know that whenever we have an OH, that's terms, that's for an alcohol right over there. If we have a halide, which does not need to be just Cl, I'm using that as an example. Some textbooks will use X to mean a halide. And in that case, it's going to be talking about fluoride, chloride, bromide, or iodide. These will obviously be attached to something else, right? So these will not just be floating on their own, because if they're floating on their own, we give them different names. But if it's attached to something, it will have the IDE ending. Now, we don't normally see fluoride much in organic chemistry. It's kind of reactive. It makes things go a little bit crazy. So, when you're actually going to look at the reactions, a fluoride reaction will most likely kill you. So you're kind of really want to avoid that. You won't see it too often, but for the sake of the video, you can consider it part of the groups of the X that will be considered. So if your textbook uses X and you just have that, an F, a Cl, a Br, or an I attached to some carbon chain, or the R rest of the compound, you're looking at an alkyl halide. And those top two are the ones you're going to be looking at the most. Moving on, we have an amine. This is when you have an NH2 group attached, and since nitrogen likes to form only 3 bonds, we'll always have a lone pair of electrons here. This will always be at a terminal group, so there'll be nothing attached to this side of the amine group. It's always going to be like that, and it'll be at the end. Now, a good way to remember this, if you've taken biology 1, which you most likely have taken biology 1 before you take organic chemistry 1, you might be familiar with amino acids. So let's write this out right over here: amino acids. Now you can look at the word amine, and you can kind of see a resemblance to the word amino. It just has a different letter on the end. So this might be a useful trick. If you remember looking at amino acids, you'll know that they have the structure that typically looks like this. It'll have one group will have a hydrogen right there. It'll have a COOH, carboxyl group, and over here it'll have what we sometimes call an amino group, but it actually is NH2. It's an amine. So and then you obviously have your your differentiating group right there. That's the typical structure for an amino acid. So we see this right over here. We see this still the amine, functional group right here, and we can use that kind of like a little trick to remember. That's just the way I remembered. If you don't remember your amino acids, don't worry, you can just simply memorize it like that. This type of stuff does just require grinding memorization. There's not many tricks. I'll try to give you the little ones that I have, but this really just requires you to just keep writing them out and drawing them and memorizing them until you have them thick in your mind. Epoxide ring, that you'll see once in a while. If you're using the textbook that I use, which is Organic Chemistry 9th edition by Francis A. Carey, there is a little bit of a chapter on epoxides. Now note for this structure right over here that the R's do not need to be equal to each other. So I'm going to scroll down just to get a little bit of space to draw because I'm running out of space. Do I have any space? Oh, I have some space up here. Perfect. Let's use this instead. So we see that in the epoxide drawing, I drew this out right over here. R, we have our O, carbons are linked together, and we have R and R. In this situation, and in most of the situations that I'm showing you, R does not need to be equal to R. So these do not need to be all the same thing. So this, and this do not need to be the same thing. So for an example, something that would be considered in epoxide would be simply something like this. Say we have CH3, we have CH2CH3, and we have we can put another CH3 here, and then over here we can have CH3 CH2 CH2, and if we fit another one in there, yes, yeah, we can. So you can have something like this, and that would be considered an epoxide. It still counts as epoxide. The only requirements you're looking at to have an epoxide functional group is your oxygen right here. Your oxygen needs to be connected to 2 carbons, and those 2 carbons need to be connected to themselves or each other. So you basically want to form a ring, a triangular ring, like a cyclopropyl kind of thing going on, but instead of having 3 carbons in your cyclopropyl or propane ring, you'll have an oxygen. So that constitutes an epoxide, and obviously the oxygen has its lone pairs of electrons right here, so it will not form another bond unless it will get a positive charge. But that's moving into stuff that gets a little bit advanced. So epoxides, that kind of doesn't, we will not look at the naming of epoxides in Organic Chemistry 1, but the concept of them might appear in the chapters, especially if you're using the same textbook that I am. Ether linkages will appear in Organic Chemistry, and you're going to want to know that an oxygen can connect like this. So for example, obviously it has its lone pairs right there, and these 2 R's do not need to be equal to each other. So we're going to move back up right over here just so we can draw it out a bit more in detail. An example of an ether linkage that would be considered fine would be something like this. We have our oxygen in the middle. We can draw the little electrons on the top and the bottom just so you know that it's not looking to make any more bonds. And then we can have whatever we want. We can have this. Can get a bit crazy if you want. You can go absolutely crazy and draw whatever you want. This can go on honestly forever if you really want. We'll just end it off right here. But as long as you have this over here, an oxygen connected to 2 carbons, the R's will need to be carbons, but they don't need to be equal to each other. So in this case, this is considered an R, and this whole thing over here is also considered an R. So the R, it doesn't need to be equal to each other. So these things obviously not equal to each other. And that's something you're going to want to look at a lot, because you might be asked to, how many isomers, and when you're looking at an isomer, you just want to see how many different ways can I arrange these things. Now you might be given an oxygen, and you might be given a couple carbons and a couple hydrogens. Now you might automatically say, okay, let's go and make a hydroxyl group, and let's make an alcohol. Now you're going to make your alcohols, you might see, okay, I see that there's 3 possible compounds. But then in reality, you miss the ether possibility. And we're going to cover this later on, because I'm actually going to be doing some final exams from, the place that I actually wrote my organic chemistry. I'll be taking final exams, and I'll be solving them. And that was one of the questions that was on there, and it tricked a lot of people. And you need to know that that's a possible way to put your oxygen inside a carbon chain. You can fit right in the middle, and it's an ether linkage. So the ones we're going to look at now are looked at a little less often. When you have a C triple bonded to an N, obviously the N likes to make 3 bonds only. It's going to have its lone pair right here, so it's done. There's nothing going to be coming on the end, so it'll be a terminal pair. You'll have a nitrile group. Now don't get that mixed up with a nitroalkane, which is when you have your R group, which is attached to a nitrogen. Remember, the nitrogen will draw its little pair right here, and it'll have an oxygen, two oxygens attached to it. So you really don't want to get that mixed up with the ones we just saw with nitrile. Those, the names are kind of the same. So you don't see those too often. You'll probably see nitroalkane more than you'll see nitrile. But in terms of naming, you might be asked to identify these types of functional groups on a big compound. But in terms of actually going in depth with nomenclature, you really don't need to worry about it. Now, the one that a lot of people get mixed up for is this is where it gets a little bit confusing, because we see in this situation we have one of our little compounds here has an H, and the other one has an R. So this R over here will be anything but H. We'll write that out. Anything but H. And obviously in this case it is only H. So we're going to have two different names, and these names are pretty different from one another, and I'll give you guys a trick to remembering it. So the one with the H, you have your R, then you have a sulfur, and then you have an H, a hydrogen. We're going to be calling that a thiol. Now we'll go look at the name of the other one first, and I'll show you guys my little trick to remembering these. So the one where we have an R group, or the rest of our compound, your sulfur, and then anything else that's not an H is actually called a sulfide. Now these have pretty different names, and there's, you got to memorize what the names are, but if you're worried about getting confused between the two of them, just know the one that has the H over here, the hydrogen, has an H in the name. If we look over at the sulfide, there's no H in that name anywhere, so you don't need to worry about getting confused. The H in thiol, connect that right there to the hydrogen attached to the sulfur. Unfortunately, there's no other way to really remember. I mean, sulfide, I guess, there's an S in it, but there's also an S over here. So it's really, you got to memorize the two names, and if you're worried about mixing them up, well, just look for the one that has an H in it, and that'll be the one that you can associate with the proper compound. And the other one, the thiol or the sulfide with an S in it, you can associate to the one with the R group, or the rest of the compound, or anything that's not an H. So moving down, these ones will appear quite often. I'm sure you'll see them in the beginning of Biology 2 if you've taken it already, but they're the three possibilities where you'll have a C triple bond. Well, there is more, but these are the common ones. And the ones over here, these two ones, the one with an H, because we can see what's different here. We can see that there's C triple bond O, C triple bond O, and C triple bond O, and obviously R, R, and R. So we're going to be looking at the differences between each one. This one over here has an H, this one here has an R, and this one over here has an OH. Now this one we've seen since the beginning of taking chemistry. It's a carboxyl group, or it's a carboxylic acid. Or a carboxyl group, whatever you call it. So that one, it gives a lot of acidity to your compound. It's very polar, and it'll make the protons very capable of being lopped off, so obviously making it acidic. If it can donate protons, it's likely to be acidic and very acidic. So having a carboxyl group or carboxylic acid portion of it will make whatever compound you have that much more acidic. So we're going to try to distance ourselves from this one here. We know that when we have an OH attached to this general formula of an RC double bond O, we're going to have a carboxylic acid. Now these two over here are called carbonyl groups. And I'm going to put arrows just pointing to both of them because they're both considered carbonyl groups. So a carbonyl group will be having that C double bond O structure, and you don't have an OH. Anything but an OH, you will consider it a carbonyl group. Now it does get even more in depth, because now when you have an H, you'll have a different name for it, and when you have anything that's not an H, and obviously anything that's not an OH, you'll have a different name. The one with the H is called an aldehyde. And don't worry, I have tricks for them, tricks for everything here. And the one with anything else, which will mostly be a carbon chain going somewhere else, will be called a ketone. Now you'll definitely see these in the beginning of Biology 2, because it's the composition of sugars, glucose, fructose, they all differ because of these little things. The best way to remember this is look at the structure of formaldehyde. Aldehyde, think of it, aldehyde, formaldehyde, they sound the same, right? So what does formaldehyde look like? We see this in solution chemistry. This is the structure for formaldehyde. Now look, there is the hydrogen right over there. So you can automatically associate the aldehyde with formaldehyde. So formaldehyde is an aldehyde, and we can connect this right over here to the aldehyde. And then the ketone, well, that's the one. It's the one where you have to know both names. And then when you're worried about seeing which one's which, well, then you figure out what one of them is, and then by process of elimination, the other one has to equal the other thing. So we're just reviewing one more, because this can get a little bit confusing. When you have your C double bond O, and you obviously have some R group, your carbon chain that's attached to it. If the other thing that's attached to your carbon is a hydrogen, you'll have an aldehyde. If it's a OH hydroxyl group, you'll have a carboxylic acid or a carboxyl group, sorry. And if it's anything else besides those two things, you'll have a ketone. Gets a little bit confusing. If you need me to explain it a bit clearer or make a specific video just for these three things, I'll do it. Just leave a comment below and I'll answer that as soon as I can. Now, your other possibility, and it keeps expanding, these last four that I have here are very rarely looked at in organic chemistry. So this, unless your teacher specifically tells you that you need to know these, you really shouldn't, get worried about them. I'm just putting them on here because they are in the Organic Chemistry 9th edition by Francis A. Carey book. So in case you're using that book and you want to know them all, well, I'm going to provide you with a little bit of explanation right here. So referring back to what I was saying before with the carbonyl and carboxyl groups up here, if your R group is actually a halide, an X, remember X meaning halide, we see them over here. I have a little chart up there. If X is a halide, it actually becomes an acyl halide, acyl halide. I don't know how to pronounce this. Acyl. You get the point. I never use these. I've never looked at these in my Organic Chemistry 1 course, so I haven't even practiced pronouncing them. I'm just putting them out here so you can see. If you have the X right there, or your halide, it becomes an acyl halide. Moving down, if we have this over here, which it gets a little confusing, it's the mix between two ketones. So we see that this here is a ketone, right? We have our C double bond O. It's attached to an R, and it's not attached to any of that other stuff, a hydrogen or an OH group. It's actually, we have our second one right over here. So we have ketones. Let's try ketone out there. We have one, and we have number two. And in the middle, we actually have an ether linkage. Like we saw before, when an oxygen is connected to two other carbons, we have an ether linkage. And then obviously we have our R groups on our rest of our compounds, some other carbon chains in the other direction going into the other sides. We have an acid anhydride. Once again, something you're not going to see very often, and it's just only for the people who want to know every single portion of organic chemistry. I'm giving you guys the opportunity to see it. When we have just one of those, so say we didn't have that second ketone group that we saw above here. Say we only had one ketone. I'm writing them out so you guys can practice your naming. Ketone. And we just had an oxygen. It's not necessarily an ether linkage. Obviously, if this would most likely be a carbon, it would be considered an ether linkage. But we don't have that second ketone group. It's called an ester, is the name for it. And moving down to the last one, we have an amide. We don't want to get this confused with the one we saw before, which is an amine. It does get a little bit confusing. So don't memorize this if you don't have to, because you're going to start getting confused. And you're going to use the word amide instead of amine, like the one we saw above when I gave you guys the amino acid example, this one over here. You really don't want to get that confused with the amide. So, if you don't need to memorize it, don't look at it. But in this case, we obviously have our ketone group. And then what's actually a carbonyl group, because this can technically be a hydrogen, but this is getting into detail. And then we have a nitrogen. And then rather than having two hydrogens, or it could be two hydrogens, but then you have your R groups. It could be anything. Obviously I shouldn't have doing that. So an amide is essentially an amine next to a ketone / carbonyl group, because it can technically be this can technically be an H over here, so it could technically be an aldehyde, but we don't need to get into that kind of detail. So there's a lot of material in this. What you should take away from this video, no matter which course you're in, definitely these three compounds you're going to want to know. That's definitely going to appear on your test for sure, especially at least for biology 2. So you're going to want to know it now. You want to understand ether linkages, and I'll put some questions up, some problem solving with ether linkages, and making you guys just remember to when you're looking for isomers, you're going to want to consider that you can possibly form an ether linkage. You can have your alcohols and your aldehydes. Alkyl halides, sorry, and those are the ones you're really going to want to focus on the most. So this video has been confusing. I know that there's been a lot of information that I was trying to just get out there for the people who just need the information. If you want me, I may make some specific videos regarding some of these and giving you guys like what properties they contribute to organic compounds and compounds in general. Like what's their purpose in life? Because just by memorizing the names, you will not really get a good opportunity to memorize. To know, appreciate them. You need to appreciate them, and you won't be able to do that unless you actually have knowledge about what they do. So here's the other stuff I drew before. So thanks. If you have any questions, feel free to leave them below. And thank you very much for watching. Have yourselves a great day.